All right. So last what we discussed was the introduction to oxo acids. We
Hmm.
have chlorous acid, chloric acid, and perchloric acid.
Yes.
This is the acidic strength. The stability varies this way. And when it comes to acidic strength of HClO3 and HOCl, this is how it will vary. Okay. This is where we
Hmm.
stopped it. Clear?
Yes.
Now, if you compare the reactions of, compounds here, starting with, Cl2O and all. So check out basic reactions here. Cl2O, when you react with HgO, will become HgCl2 dot HgO plus Cl2O. This is how it can be produced, correct? And Cl2O, when you add it to
Yes.
water, that becomes HOCl. So this is a kind
Yes.
of preparation for HOCl. And
Yes.
Cl2O, because it is an hypoacid anhydride, when you add it with NaOH, acid-base reaction will take place. NaOL, NaOCl plus H2O will be formed. NaOCl, when you react with OH minus, because OCl minus will make it to further oxidize, so this will become Cl minus and further oxidizes to ClO3 minus. In fact, the
Right.
same logic appears even with Cl2 when you are heating it in the presence of OH minus or hot and concentrated solution. If you take, that is the same thing which you will get. Okay,
Right.
so you will get this as Cl minus and ClO3 minus. Now, Cl minus and ClO3 minus, if you subject to barium, it will become BaCl3 and BaClO3. And this on adding to dilute H2SO4, you can get barium sulfate precipitate
Okay.
and HClO3 forming. And this becomes the preparation reaction for HClO3. Got it?
Yes.
And lastly, Cl2O, when you add it with NaOH, you'll get NaCl and NaClO3. This on hydrolysis, that is only ClO3 minus on hydrolysis will convert into ClO4 minus. Basically, it will get further oxidized and H plus will get reduced. Hmm.
Right.
And that's how you'll get HClO4.
Right.
Got it? Right.
Yes.
Next, ClO2 reactions. If you notice NaOCl and H2C2O4, so that is oxalic acid with NaClO3. Oxalic acid will convert itself into ClCO2 and chlorine will get reduced to ClO2. Some part of that will still remain as oxalate and water. Got it?
Right.
And oxidizing agent, when you react with SO2, this will reduce into ClO2 and SO2 will get further oxidized to NHSO4. And
Yes.
this ClO2 on hydrolysis, because it's a mixed oxide, it will give HClO3 and HClO2. And if you add with NaOH, it will give NaClO3 and NaClO2. And see,
Yes.
NaClO2 also acts like a bleaching agent. That is
Right.
ClO2. When you react with H2O2, it will become O2 plus NaClO2. And this NaClO2 on hydrolysis will give you HClO2. That's how it can be prepared as well as used as a bleach.
Yes.
Got it? So this is the part that is usually being asked. Okay. Now, what are
Right.
the other things which we need to learn from here is about, what is the bond distance? What is the bond angle between them? So if you notice, for example, if you have HOCl, okay, in the case of
Right.
HOCl, the ClO bond length, if you compare, this is the bond length I'm trying to compare, bond length, that will be around 1.7 Armstrongs, correct? And the bond
Yes.
angle of OClO, the bond angle, if you compare, correct, that is, that is almost linear, correct,
Yes.
right? OClO bond तो नहीं है, so I'll just write down this as non-existent. Clear?
Yes.
HOCl का bond है. And you know that ClO bond energy wise, okay, because the bond length is, larger, it would be around 209 kilojoules per mole.
Yes.
The energy. Okay. Just to give you a perspective, it's not like you have to mug up this. So just understand how the bonds are. Next, HClO2. HClO2, the bond length is around 1.68 angstroms. Got it? And the bond angle of OClO is around 111 degrees. Correct? And
Okay.
bond energy, in this case ClO, because the bond length is decreasing, what should happen? Bond energy should increase.
You should increase.
And this is what will happen. And then HClO3, the bond length, if you compare, that is around 1.57 angstroms. And bond angle of OClO is around 106 degrees. And the bond energy for this Cl and O is around 244. Okay. Although,
Yes, sir.
although you can see the bond length is smaller, the energy required is also lesser here. Okay. This is a slight exception, but not with a larger value, just a small exception there.
Hmm.
Next, bond length wise 1.45 angstroms. So bond angle OClO is 109 degrees, 5 minutes. And bond energy wise, ClO will be 364 kilojoules per mole. Okay.
Yes,
So
sir.
from here, there is one thing you can notice that breaking the ClO bond is stronger than breaking ClO4 bond, right? Which means
Yes, sir.
if you compare the oxidizing power, correct?
Hmm.
Although this chlorine is at higher oxidation state, you will notice that ClO minus will have a better compared to that of ClO2 minus and ClO3 minus, which is almost the same. And then comes ClO4 minus. Done?
Yes, sir.
So this is the, I mean, just for this information, we have used that part. Okay, beta.
Yes, sir.
Right. Next. Uh, you can see the acidic nature, HClO3, HbRO3, and HiO3. This is how the stability would be. The acidic nature of HClO4 will be in a similar form. Acidic nature of HOCl up to HClO4 will be in this form. Thermal stability will be increasing. Just now I told you bond energy is more for this part. So that's where thermal stability will also be more. Oxidizing nature will be decreasing. That's also I just discussed. Clear?
Yes, sir.
And HiO4, which is known as periodic acid, which exists as Hi4.2H2 or H5IO6. This is a
Hmm.
structure. Now, this structure at around 100 degrees, it will lose the water molecules, convert into HiO4. And HiO4
Right.
on further heating will convert into I2O7, and which on further heating becomes I2O5 plus O2. Okay.
Right.
And this I2O5 solid which is forming, that is specifically used for detection of carbon monoxide gas in quantitative analysis. That is, 5 moles of carbon monoxide will convert into 5 moles of dioxide, making a
Dioxide.
blue color glow of the uh, fire, and I2O5 will get reduced to I2. Okay. So this is some important reaction on HiO4. Clear, beta? Right. Now, see the next part, which is about interhalogens. Okay. Interhalogens is X, X dash, X, X3 dash, X, X5 dash, and X, X7 dash. Okay. And
Yes, sir.
whenever we have this, the X dash is always more electronegative and X is always less electronegative. Okay.
Okay.
So that's why you will see X, X dash, you can have CLF, BRF, IF, BRCL, ICL, IBR. These are the ones which you can get. Okay.
Okay.
And X, X3 dash, CLF3, BRF3, IF3, and ICL3.
ICI3 ट्वाइस
XX5,
का क्या मतलब होता है?
मतलब ICL3 डाइमर की तरह बन जाएगा.
अच्छा. ओके.
Okay. CLF5, BRF5, IF5,
फाइन
and
फाइन.
IF7 only one exists. That is, I mean, iodine is the only one which can make this as XX7. Okay.
Hmm.
And all interhalogens are diamagnetic in nature. They are covalent compounds only. Okay. Now, few important things starting from structure. If you notice, ClF3 will have a structure like this, which is a bent T shape. In bent T shape, you know that this bond angle alpha 1 will be greater than that of bond angle alpha 2 if you have BrF3. Okay. That makes sense because bromine is bigger in size, so therefore it can hold at a smaller bond angle. Here, chlorine is smaller in size, so it makes a larger bond angle. Okay. But
Hmm.
both will have bent T shapes. While BrF5 will have a square pyramidal with a hybridization of sp3d2. Correct.
Right.
And uh, bond angle of FBrF is not 90. We expect this to be 90 like this, correct? But
Hmm.
problem is there is a lone pair that will keep pushing it. So instead of staying 90, it will start slightly coming up and everything will be less than 90 degrees. So this was a question asked in JE once. What is a bond angle of FBrF? You know, or sorry, how many 90-degree bond angles do we have? Answer is 0. Okay. Next,
Right.
ICl3 will usually get dimerized to form this compound. And here, iodine will have two lone pairs, one in above the plane and below the plane. And that's how it will make up a planar structure in both the cases. Clear, beta? So we
Right.
will get a square planar form here, correct? So
Hmm.
CLI, we will have this as ClICl. Bond angle is 90 degrees or 180 degrees here,
Right.
correct?
Yes,
So
sir.
this is a square, but that's why I2Cl6 will have a smooth surface, correct?
Hmm.
And now notice the reactions. XX dash reaction plus H2O will becomes HOX. Remember the one which is less electronegative, that will become the uh, uh, positive oxidation state. So here HOX is forming. And this more electronegative one will always become hydroacid, that is HX. Okay. So it will
Hmm.
become HX dash. XX3, same thing, HXO2 and HX minus. And XX5 dash will be HXO3 and HX dash. Correct? So this is how the
Right.
hydrolysis will take place. Clear, Buddha?
Hmm.
Now, before coming into that, check out what is the preparation of interhalogens. See, chlorine and fluorine, if you have around 1:1 degree at around 200 degrees Celsius, it will become 2 moles of ClF. If you have excess
Okay.
amount of fluorine, usually it will become ClF3. Okay. And if ClF3 is further heated with F2, of course, here also it can happen. But if as long as there is any chlorine present, the ClF5 formation is less. So first you collect
Right.
this, then only react with F2. This time you will get ClF5. Br2F2 in the presence of inert gas like N2, you will get BrF3. And when you react with excess, you will become BrF5. I2F2, 20 degrees, F3 will form. And 250 to 300 degrees, F7 will form. With chlorine, you'll get ICl solid. With excess chlorine, you'll get ICl3, which will become dimer product here. Okay. So these are
Hmm.
few preparations. Honestly, JE does not ask directly with the preparation, but once they have mentioned about ratios, if you're 1:1 ratio, what is the con? It will
Okay.
not be usually asked with what temperatures and all. Okay.
ठीक है.
Interhalogens are more reactive than halogens due to its electronegative difference. So you can see Br2 and HOBr will have HO and Br here, correct? So this is the one which will have. That is the reaction which will happen. And second thing, if you notice BrCl will split much more easily, Cl minus and Br plus. So if you compare this versus this is an interhalogen with a normal halogen. So the second reaction happens even faster.
Right.
Got it? And now you check out what is polyhalides. Okay. Polyhalides is when the same halogen, the halogen combines with the same atom's ions. So that will become polyhalogens, I3 minus kind of structure. So I3 minus is
Right.
actually a linear and sp3 hybridized structure. The same forms with Cl3 minus, Br3 minus, and F3 minus you will not see because it cannot expand its octet. Stability
Right.
wise, larger the size, more is the stability. So I3 minus is more stable than Br3 minus and Cl3 minus.
Hmm.
And that precisely the reason because larger size will always make it more stable. CsI3 will be more stable than Ki3 than NaI3.
Hmm.
Okay. So this type
Right.
of formations are called polyhalogens. Okay. Now,
Right.
what are the reactions of polyhalides? Okay. So
Hmm.
polyhalides can be of this kind where you have, two interhalogens. This is also polyhalide kind of a form. So ICl plus Cl, it will give you ICl2 minus. Okay. KCl plus ICl3 will become ICl4 minus. IBr plus Cl will become IBrCl minus. And if it is already in a complex form, let's say this is in a complex form here, and on heating, this is to be learned carefully that between the halogens, the one which carry the more ionic character that will combine with the group 1 elements. So between these three, which is more electronegative, fluorine. So that can make a better ionic compound. So that will separate out and ICl will be reduced as, ICl can be released as vapors. Okay. Same way
Right.
between Br, Cl and I, KCl can form and IBr can be eliminated or removed out. FBrCl, F can be removed out. This can be separated with BrCl. Okay.
Hmm.
The next one is about pseudo halogens. Okay. Now, anions
Hmm.
which are linear and contains at least one nitrogen, those are called pseudo halogens. And you can see
Hmm.
Cn minus, OCn minus, SCn minus, SECn minus, ONC minus, N3 minus aside,
Right.
and NCN2 minus. These are all called pseudo halogens.
Hmm.
Okay. And above anions have a similar behavior to that of halides. Okay. And in fact, Cn minus is the
Right.
most common pseudo halide, which we will take it in a very similar reactions as that of chloride or a bromide. Hmm?
Right. Hmm.
For instance, check this reaction. Cu2 plus I minus will first form CuI2, but CuI2 is unstable. It will decompose to form Cu2I2 plus I2. Okay. Now the same nature happens with cyanide also. With cyanide, CuCN twice, which is a white PPT. This is a white PPT. And that will convert into CuCN, which is also a white PPT. And this will give away Cn twice, which is called cyanogen gas. Just like iodine gas here, you'll get
Cyanogen.
cyanogen gas. If you take SCN minus, first you'll get actually a black PPT. Then you will get a white PPT on decomposition, and that will convert into SCN twice, which is thiocyanogen gas. Okay,
Hmm.
and see AgNO3, when you react with X minus, it will become AgX. With cyanide, it will become AgCN. With SCN, it will become AgSCN. Okay, with Cl minus, it will become CuCl2. With chlorine excess, you'll get CuCl4 2 minus. And
Right.
with cyanide, you'll get this 2. And with excess of cyanide, you'll get this complex. Got it?
Right.
Chlorine and water will become HOCl and HOCl. Just like that, cyanogen gas will also become HOCN and HCN. So you
Hmm.
can see a similar behavior can also be observed in pseudo interhalogens. That is BRC, just like BRCl, we can have instead of Cl cyanide, again we can have a similar reactions. Got
Right.
it? Same with ICN, same with ClCN.
Okay. Hmm.
Last thing, you can notice KClO3 plus HCl will give you a chlorine gas because this Cl minus will try to, reduce the ClO3, convert the rest of the chlorine into ClO2
ClO2.
and
Hmm.
KCl and H2O. So basically,
Right.
here we have 2:1 ratio of ClO2 and chlorine. Okay. This solution's name is called euchlorine solution. Got it?
Euchlorine.
Euchlorine. It's
Okay.
called euchlorine solution. Got it? Now,
Okay.
if you notice some, Important information. Important information.
About you, chlorine.
No. About these interhalogens compounds,
Acha.
if you notice, and in general, what are the things we need to know?
Hmm.
So, first one, ClF3 and BrF3 both are used in production of in production of UF6. Okay, in
Right.
enrichment of uranium 235. Correct.
Right.
This is one important thing that will be used. Okay, so
Hmm.
basically, wherever there is a uranium that is been treated with 3 moles of ClF, okay, F3,
Right.
which will convert into ClF6 plus 3 moles of ClF. Okay, so this is how you will get this ClF, sorry, UF6, correct? That UF6
Hmm.
is slowly converted and then again decomposed back to uranium, which is enriched form. Got it? So
Right.
typically that's how we will get that. Okay, next.
Hmm.
The other important information that we need to know is about fluorine. Okay,
Hmm.
uh, fluorine occurs in various forms. Fluorine occurs in various forms here. One is
Hmm.
fluorspar. Okay, fluorspar, correct, which is
Hmm.
CaF2, correct.
Hmm.
Next is cryolite. Cryolite is Na3AlF6. If you remember, this was used in metallurgy for
Hmm.
used as a solvent for extraction of aluminium. Next, fluorapatite.
Hmm.
Fluorapatite, which is 3 moles of calcium phosphate, got it, dot CaF2,
Hmm.
got it. These two are the
Right.
uses which you need to remember. Clear?
Hmm.
Fluorine, if you notice the preparation, right? So mainly it is done by, prepared by,
Hmm.
prepared by, okay, uh, Whitlaw, correct? Whitlaw
Hmm.
Grace method.
Right.
Whitlaw Grace method. Basically, here we will electrolyze electrolysis of fused KHF2 is been done. So wherein you can get this as K plus and H, sorry, here like this HF, and here uh, H and F with H here, correct? Very mechanical.
Okay.
Like this H and F ka bond hai, and here you have a hydrogen bonding with F minus like this. Okay, so these two are
Yes.
the ionic forms which will be used for electrolysis. Got it?
Yes, sir.
Right. And next,
Yes, bro.
yeah, yeah. Next thing is fluorine forms, which we'll be noticing again in group 18, XCF2, XCF4, and XCF6 with xenon at
Hmm.
various compositions. At different compositions, you will get this form. Clear,
Right.
beta? This is something we need to remember. Next, since fluorine is an oxidizing agent, so we can see these reactions happening at electrolysis as well. KHSO4, when you treat with F2, F2
Yes,
will
sir.
get easily reduced. So that will convert into 2 moles of HF and you will get K2S2O8. Okay,
Right.
clear. So that's how we can get H2, K2S2OF, and K2S2O8 can be used to with
Hmm.
heavy water So we can get this as D2O2 plus K2SO4. So that's how we can make the uh, peroxide of heavy water. Correct?
Right.
And HF is mainly used in etching glasses because it can easily react with glass. So it will be used as etching glasses.
Right.
Okay, etchings or marking the glasses. Got it.
Yes, sir.
And you know that fluorocarbons, which we call it as freons, right?
Yes,
Used
sir.
as
Yes, sir.
refrigerators. Freons, which is C, Fx, and Cly, are used as refrigerants. They are used as refrigerants. Correct?
Right.
You might need to know that NaF as well as Na thrice AlF6, which is cryolite, are also used as insecticides.
Insecticides.
They are used as insecticides. Correct?
Yes, sir.
And F2 is used in rocket fuels also. This is used as a part of rocket fuel as well. Okay. Next, if you compare SF6, right? SF6 is a gas. Okay. It is used as insulator gas, correct? In high
Right.
voltage electricity. Used as high voltage electricity. This is what you will use. Got it? Now, coming to the bleaching powder, correct? When it comes to bleaching powder, there are two important things we should know. One is what is the percentage amount of chlorine present in it? Okay. So let's see. Percentage of chlorine in bleaching powder. So how do we get to know this part? See, first let us understand what is the reaction that is happening. Okay. See, calcium hydroxide, when you treat with chlorine, you can get into a formation called CaOCl2 plus H2O. Got it?
Right.
And if you keep it for long standing, then CaOCl2 will get decomposed also. So in fact, you can see decomposition happens this way. It will convert into CaCl2 and CaClO3 twice. Okay. 1 second.
So 1 second, I'll be back.
Second.
Yes.
See, for long standing, this is how it get decomposed, or we can say it can undergo disproportionation. Okay.
Disproportionation.
And at the same time, if by chance if you keep it for some time in cobalt salt like 2CaOCl2, if it is been kept in the presence of cobalt salts, correct,
Right.
CoCl2, then it will convert everything into CaCl2 and O2. So O2 gas will be released in this case. Got it? Suppose next, if we have small amount of acid added, being added, then you'll have 2 moles of CaOCl2 reacting with something like H2SO4 is the acid which I'm taking. Then you'll get this
Right.
as CaCl2 plus CaSO4 plus HCl plus O2. This is the
Right.
overall reaction that will happen. Okay. But this is the normal behavior of bleaching powder. Correct. Now,
Right.
When we understand what is the capacity or the quality of bleaching powder, quality of bleaching powder is to do with what is the available chlorine in that. So this is the calculation which we need to do. Available chlorine, available chlorine
Hmm.
in the bleach. Okay.
Right.
So check out. So how do we do that? So what we make it, we add excess amount of acid this time with, let's say, dilute H2SO4, or you can take acetic acid also. Okay.
Right.
CH3COOH also you can use, but take sufficient or excess. Correct. So
Right.
that everything will convert either into acetate form or a sulfate form. Okay.
Right.
And you will get chlorine gas released in this case. Agreed? This is what will happen
Right.
if you take excess amount. Clear, beta?
Yeah.
You can or directly take carbon dioxide. Sometimes in the question, carbon dioxide is given. It's one and the same. It will become CaCO3 and chlorine gas is released in this case. So you will
Right.
have good amount of chlorine gas getting released. Okay.
Hmm. Right.
Chlorine gas being released. Now, usually the amount of chlorine gas that is released, that depends on, I mean, whether it is a good bleach or not, that depends upon how much percentage is available, correct? So around 35 to 38 percentage of Cl2, okay, available
Hmm.
chlorine uh, is present in a bleaching powder, is present in bleaching powder. This is called as good quality bleach. Good quality bleach, correct? So this is the good quality bleach which we have. Okay.
Right.
Right. Now let's see how it can be used in calculating the percentage here, or how much is the available chlorine here. Okay. So we know that stoichiometrically, stoichiometrically, how much it should be present. Notice
Hmm.
percentage chlorine will be equal to 71 into 100 divided by 127. 127 is the molar mass of Cl2, CaOCl2, 127, correct? So how much is
Hmm.
a percentage? So maximum best quality, I mean, of course, if you have only quality, only chlorine, nothing else, no other components or any impurities are present, that means how much it should be? 55.9 percentage should be present. Okay, what I said, even if it is around 36 to 38, we call it as a good quality bleach. Is this point clear, beta? Any doubt in this case?
Yes, sir.
Let's see the example, how it is being asked. It is being asked as 3.55 grams of bleaching powder, this much bleaching powder, correct? When treated
Yes,
with,
sir.
when treated with acetic acid in excess, correct?
Right.
Uh,
Yes, sir.
acetic acid and uh, excess amount of excess amount of I2, excess amount of I2, clear?
Yes, sir.
Excess amount of Ki. Then I2 released, okay. In fact, he didn't say I2 release, released gas sometimes. So you should understand that it is I2 released.
Yes, sir.
I2 released requires, I2 release requires 60 ml of 0.6 normal hypo, hypo solution. Calculate percentage available chlorine in bleaching powder. Okay.
Okay.
What might be the reactions happening? See, CaOCl2 plus acetic acid, CH3COOH, that must be making it as CaCH3COO twice plus
Right.
Cl2 plus H2O. Done.
Right.
Now, if you notice the ratio wise also, we can have 1:1 mole of chlorine, correct?
Yes, sir.
Now, the released chlorine, when you react with excess amount of Ki, that will
Yes, sir.
oxidize this into I2 plus 2 moles of KCl. Understood?
Yes,
And
sir.
this released iodine is what we are sending with hypo Na2S2O3 to make a iodoform reaction, which will make it
Right.
as Na2S4O6 plus 2 moles of NaI. That's how you're
Hmm.
detecting. And beta. Now, can I say that
Yes, sir.
the number of moles of iodine, how many released, are the same moles of chlorine also?
Yes, sir.
So you can see first equivalents of iodine. Equivalents of iodine will be same as equivalents of Na2S2O3. Correct?
Yes, sir.
So equivalents can be written as N1V1. Correct? Sorry, here we already have that N into V. So normality, how much it is being given? 0.6 into 60. Correct?
Yes, sir.
So that makes it how much? 3.6 uh, milli equivalents. Okay. Now, what will be the
Yes,
number
sir.
of moles of I2 beta? Number of moles of I2 will be equal to number of equivalents divided by valency factor. Valency factor in this case is 2. So 3.6
Yes, sir.
divided by 2. So how much? 1.8 millimoles. Okay.
Yes, sir.
So number of moles of I2 will be same as number of moles of Cl2 will be same as number of moles of bleach. Correct?
Yes, sir.
Therefore, we know that number of moles of chlorine available is 1.8 millimoles. So what is the weight of chlorine? That is 71 into 1.8 into 10 raised to power of minus 3 grams. So from there, percentage chlorine available, Cl2 available, will be equal to weight of chlorine by weight of bleaching powder into 100. Done? So that is equal to 71 into 1.8 into 10 raised to power of minus 3 divided by weight. How much is given? 3.55. 3.55 into 100. Clear, beta? This is
Yes,
coming as
sir.
36%. So that's how you calculate the percentage available chlorine. Clear?
Chlorine.
Please
Yes,
do
sir.
check once. Any doubt in that?
No, sir.
Right?
So, CaCl2, CaCl2. Um, got it, sir.
Right. So this is how much you need to learn from halogens. Correct.
Like
Last thing,
17.
just an additional point is oxidizing properties of bleaching powder. Oxidizing properties of bleaching powder.
Yes, sir.
So if you notice, let's say CaOCl2 is present. hmm, That
Right.
if it reacts with H2S, what do I get? If it reacts with uh, Fe plus 2 in acidic medium, what do I get? Okay. If you react with NO2 minus, if you react
Okay.
with ammonia, if you react with I minus in the
Right.
presence of HCl, clear.
Right.
And if you react with Ki in the presence of acid ACOH, clear.
Right.
And if you react with ASO3, 3 minus, right, then what will happen? Okay.
Yes, sir.
So in all of these cases, the product is the same. You will get this as sulfur and CaCl2. So everything you will get it as CaCl2, and this will become Fe plus 3 plus CaCl2, NO3 minus, and CaCl2. Here,
Yes, sir.
ammonia will convert into N2 plus CaCl2, correct? And iodine will
Yes.
convert into I2, and this will become CaCl2. Here also it will become I2 plus CaCl2. And
Hmm.
arsenic also converts into AsO4 3 minus and CaCl2, correct?
Right.
So these are typical products that has been observed.
Right.
Okay, beta. Right. So this is how much you need to know it from group 17 onwards. Okay.
Yes, sir.
Right. 1 second.